for this week's video, I am going to be starting a whole series of memory. Memory is a big subject. It's going to cover multiple videos. It's going to be installations. It's going to be removal. It's going to be showing you where the actual numbers are on the memory so you can read them so you know if your memory stick is a 1 gig, 2 gig, 250 meg. If you have one of those really old computers, you may have something under a gig. Single channel, multi-channel, dual channel. There's like quad channels. There's single slot, dual slot, 4 slot, 6 slot, 8 slot, 12 slot. Different configurations that you will run across in your career and at home that really will kind of throw you some curveballs. When you come to servers, you have different configurations due to how many processors you actually have. Not cores, not threads, actual processors. The actual chips that are on your computer. When you get into servers, you may have, seems like nowadays is a 4 processor, is a high-end server, and on there are multiple cores and multiple hyperthreadings per processor. So you may end up like some of these new AMDs that have 64 cores, and if you have a certain brand that uses that processor and has 4 of them, it's 4 times 64 cores. That's how many cores you can have on a high-end server. Where if you have a basic custom built computer where you have 1 CPU, you have 64 cores. I know in the older days you used to be able to find home grade motherboards that would support 2 processors. I think they still have them out there. I have not really researched them. I've seen some things out there where you can have them. I know a lot of like Apples and stuff like that usually had 2 processors on them. But I don't really deal with the Apple, but it's something, I want to bring up because when you get into servers are different than home, because with the server, they do not share the memory. Each processor has their own memory. So if it has 8 slots per processor, that means there's 8 times 4 if you have 4 processors. The actual CPU core chips. In that configuration, anytime you put memory in, it's times 4. So if you're a single running a server at a business and you're running a single channel, that means you have 1 stick of memory in there. It's configured for a single channel. If you want to go to dual channel, that means you're going to need to add at least 4 sticks of memory. If you have 2 processors in there, 2 actual chips, then it's a lot nicer because then you only have to put 2 sticks. It goes back to best practices. I have video on that, what that all means. You want to follow the best practice. The best practice on memory is to use match memory. There's a lot of videos out there talking about how you can mix and match and you can do some things, but it goes back to the video of best practices and your ghost in the machines. If you mix match memory, I can almost guarantee you will have ghost in the machines. It may not be noticeable to you, and it may really hurt you in a lot of ways that you don't realize. You may have someone that says, oh no, I've done it, and it's been fine, and they show you a video and it works, but whatever their workload is may be different than your workload. When you get into the business end, you don't want to be cheap. When you get into gaming stuff, you don't want to be cheap because you want the higher performance. You need the reliability. I have some memory here in front of me. This is for a laptop. This is just a single memory stick. If this is all you have in your computer, you're running single channel. You could grab another one, go, oh yeah, no problem. I'll throw this one in there and run dual channel. One of the issues is, I don't know if you can see, but let me flip them around. Are they the same? The chip configurations are laid out different, so that means the controller card's different. All the control configurations are different just on these two. This is where best practice comes in. This is where your ghost in the machines show up. This is why. People will tell you, no, you're fine. No, you're not. I want to tell you now so that you're aware, so that you don't spend money on something and then end up having issues and everything tells you you're fine. This is your warning. This is your notification that really what you want to do is, it's really not that hard, but you can shop around, you can find it. Worst things worse, replace both of your memory sticks. You want matching. You want matching memory. Quite a bit different. There's a lot of performance factors that come involved. There's a lot of things that happen. Run into a user that had all kinds of weird problems with their computer. I've mentioned it on another video that, we've troubleshooting, thinking it was a software issue. Finally, we got fed up. It was an older computer. Changed it out for a different one. We had an extra that we had to load all the software in, had to go through all this stuff to get it so that user could have their software, what they needed, and have it work the way they needed. After some time, it was old. We decided we're going to scrap it. We won't use it. It's too slow now. We need to buy a new system. Go to take it apart. Mixed match memory is what I found. It was the same brand, same speeds, but it was not the same memory. That's where all our problems were. It only had 2 sticks of memory in it, so it was running dual channel. People will tell you, you can do it. Yeah, it worked fine for a lot of things, but the 1 or 2 applications that user needed to use is where those problems came up. The user probably used 10 other applications other than those key 2 that had no problem. But that's where I say, someone may say, you can do this, and I've had no problems, and I don't know why people are saying this, and so on and so on. But this best practice has been in place since 386, 486, first Intel processor lines. This is the best practice for this. This is still what they follow. A lot of people will mislead you into believing you can just do whatever you want. I will not mislead you into that. For best practice purposes, it's better to pay to get what you really need. If you really just cannot afford it and you just need that immediately, or go somewhere and you find a stick that's just dirt cheap, really, really cheap, and you think it's going to work, give it a shot. But I just want you to know, if you start having issues, that's usually where all your problems are, is in your memory. I know there's a lot of people out there that know a lot about computers, and they say, well, my BIOS recognizes it, it boots, you know, there's not my memory, it's something else, and you'll troubleshoot, trying to figure it out. This video right now, covering this memory factors, is basically letting you know that this is where your problem is. Because I've seen lots and lots of posts online. I've had people ask me. I've had people I know where I've troubleshooted their computers. You know, what memory you got? What's going on? Most of the time when I tell them, take out all your memory except for one stick, put it back in, make sure you put it in the proper slot. That's another factor. It's making sure the memory's in the proper slots. Because when you have a computer that has multiple slots, a lot of them have 2 slots, some of them have 4 slots. Some of them have 6 or 8 slots. Some of the new higher end boards can have 8 memory slots. You want to make sure you know your memory's in the proper slot 1, proper slot 2, proper slot 3, proper slot 4. If not, you're going to have problems. The BIOS can recognize it because that's what the BIOS does, is sees what the hardware is. Now, once your computer starts, it goes to your operating system. Operating system is completely separate than your BIOS when it comes to this. Some things, they kind of run together. Your boot up setups and that type of stuff is interchangeable. But when it comes to your memory, it's very important that you don't mix and match. Some of the high-end boards will let you mix and match. But here's the kicker. It will default to the lowest speed of any one of those memory sticks. So if you go out and buy, $1,200 gigs a stick of memory that are the fastest on the market, and then you decide, oh, I need a little bit more, and you go out and buy the cheapest stuff on the market, you just slow down all your faster stuff. Everything will run at that slower speed. That's where you can start having your issues. That's where best practice comes involved, Ghost in the Machine comes involved, is doing things like that. Not to mention, you just spent a lot of money on something that you're not going to meet the performance factor of because you put something else in there. And one of the other factors is you may have like a Kingston memory and another brand of memory. They may be the same speeds, they may be everything identical. You can put them in the computer. You can go on the manufacturer site, you can go on the memory site, say these are compatible with that model of a computer you have, and install them. But here's the thing, they don't tell you this and this is compatible together. They'll tell you this one will work and this one will work on a certain product. It doesn't say you can use these together. That's one little factor they forget to mention a lot of times. That just because you have a memory compatibility list, that's this will work on this, is not the same as this and that in there. here's an example of what I have. It's not the proper memory for this, but it's memory I ordered so that people are aware. Matching sets. This is 2 sticks. I got another 2 sticks in the container for 4 sticks. Now, where this gets confusing is I have 4 sticks of memory. Am I running single channel or dual channel? Depends on how you configure this. There's always been a debate for many, many, many years on benefits of multi-channel. I will cover a lot of that in some upcoming videos, but it goes back to best practice. Multi-channel has always been best practice to use. Most places won't even recommend single stick memory. There's reasons why, performance reasons. I know there's a lot of videos out there talking about single channel, multi-channel, dual channel when it comes to gaming. Gaming's different. Gaming, it's refresh rates. It's a lot of other things that you can kind of measure. Even today, I'm having a hard time to find a good reliable test that says, okay, if I have one memory stick in here of 8 gig, is that better than 2 sticks of 4 gig? There's a whole world of differences here. When I got into computers, best practice was trained as the bigger size memory stick is better if you're running bigger applications. If you're doing web design or AutoCAD where you're doing huge files, you want the bigger size memory stick. So a lot of people would go with an 8 gig single stick because it was a bigger stick, because it depended on the data file size you were transferring. I'm still having a lot of problems finding actual accurate testing on this, on any memory configurations, and it always goes back to just basic best practices. It's really a hard area to cover. The one recommendation I've always told everybody is if you're going to run dual channel, you want to treat it as 2 separate entities. If you know you're going to be running big packages, don't put like a 2 gig and a 2 gig because you want 4 gigs of memory. I always tell them, think of it as you're splitting those apart. If you want to have your best performance from your system, cut your memory in half. So if you put 2 gig and 2 gig, think of you only have 2 gig in here, because that's how the file sizes should be. I always tell them, just don't cheap out on it. That's where you want to spend your money, is on your memory. So if you know you're going to be running big files, buy 16 gigs just because you want 8 gigs, because you'll have 8 gigs on each stick. Let me think what else. Some manufacturers are doing some weird things right now where they're putting 12 gigs of memory in a computer, 2 slots. Don't recommend it. It's against best practice again. You want to match your memory. Obviously, you can't get 12 gigs from 2 sticks unless you mix and match. I don't recommend it. Goes to the machines. Comes up. Goes back to what I was saying. Split your memory. Now you have an 8, you have a 4. What did I tell you about memory speeds? It will default to the lowest. What's your computer going to do? Default to the lowest. So what happened to that 4 gigs on that 8 gig stick? Not to mention, if I start doing an AutoCAD or something heavy on there, I better hope it writes to the 8 gig stick and not to the 4 gig stick. This is where you start having a lot of weird issues. Is now, where is your memory being sent? How is it being sent? Is it being split between the two? All of this is due to the software. And that's where the huge variable is due to the software. So when I talk to people about memory, I always tell them follow the best practices, standard practices, because I can't tell you how your software is going to run. All I can tell you is how to make sure you go from here to here. You don't want to be down here. You always want to be here. You always want to be up. So that whatever you're doing on your computer, you don't get the ghost in the machines. You don't get any weird issues because you didn't follow standard practice. I think I'll end this one now, and I'll start another one on how to install remove memory. So stick around. Make sure you hit the subscribe. Hit the bell so you can get the updates on the new videos. There'll be lots of videos coming out here on memory. Installation on tower, removal, showing you the labels, computer, laptop installation, removal. I've shown you laptop memory, shown you desktop memory. They're different. I think that will cover most of the basics. I will cover more of it in these other videos coming up. Make sure you hit the subscribe. There's a lot of information coming. There's probably 6 to 8 videos coming just in this set. So make sure you hit the subscribe. Thank you.